Last week, I spoke with the behavioral geneticist, Robert Plomin, and we discussed two ways that intelligence has been researched over the past 100 years. The quantitative approach that started with Mendel, the molecular approach started with Mendel, and that leads into genetics, and then the quantitative approach that started with Galton, and where intelligence was studied through behavioral studies. But your work has also touched, in addition to those, on a third approach, and that's through the brain. And I was wondering, just to get us started, which of the three models did you begin with, and what was it about studying intelligence that first gripped you?
Well, when I started graduate school in 1971, I was interested in different aspects of intelligence. And it was more some of the psychometric aspects. Psychometrics is a branch of statistics, psychometrics that were developed especially to look at tests, especially intelligence tests and mental ability tests. So I was interested in psychometrics and what they correlated with. And at the time in 1971, the question about genetics was just a simple question. Did genetics have anything to do with individual differences in intelligence or not? It was the same question that was being posed in schizophrenia in the late 60s and early 70s. Does genetics have anything to do with these complex things or not? And it really wasn't until I left graduate school for my first job at the National Institute of Mental Health that I really was exposed there to more of the biological aspects of schizophrenia and then intelligence. At the National Institute of Mental Health, NIMH, while I was there, they became interested in at the time, a brand new brain imaging technology called positron emission tomography, known as PET scanning. And they ordered one. They were getting one of the first commercially available PET scanners. And I actually left NIMH before it arrived. But the people I was working with at NIMH, they got one, they started to use it, but subsequently they left for the University of California at Irvine. I left my job at Brown University and came and rejoined them at the University of California because I wanted to be able to use this remarkable technology to study the brain. And the first study that I was able to do while my colleagues were working on schizophrenia and other psychiatric disorders, I renewed my interest from graduate school in intelligence. And so I was able to do really the first PET scan study of intelligence. That was way back in 1988. That was 12 years before MRIs became available. So it had a very long history. The beauty of PET scanning was that it showed what parts of the brain were active while a person was doing some kind of psychological task, like an intelligence test. And we just asked the simple question, while people were taking the PET scan and they were doing an intelligence test, what parts of the brain were active? And we did see some parts of the brain were active, but the real surprise was the more activity we saw in those brain areas, the less well they did on the test. It was an unexpected inverse correlation. So it wasn't how hard their brain was working that was related to intelligence. We thought it was how efficiently their brain was working. So way back in 1988, this first empirical observation of a relationship between brain activity measured with positron emission tomography, really for the first time, and psychometric test scores showed something pretty interesting. And I started from there doing more studies using PET scanning and various aspects of intelligence. And then around the year 2000, or a little bit later, we started using MRIs as well, both structural and functional MRIs. And what, right from the very beginning in 1988, critics of intelligence testing were kind of, in some ways, stunned. If their criticism was that intelligence test scores were meaningless and really were just arbitrary or statistical artifacts, to see that they were related to quantifiable brain characteristics like glucose metabolic rate, which is what PET scans measured. This gave some critics a pause for that kind of criticism. And up until that time, aspects of intelligence testing had been quite controversial, at least for 2 decades. But I began to notice with the advent of brain imaging studies of intelligence, with more and more sophisticated genetic findings on intelligence, that kind of really superficial criticism of intelligence testing and intelligence research really started to go away. And today it's really not common among people who actually know the data. There's still widespread beliefs from people who don't know the data that are not consistent with the data. But critics nowadays are, there is a lot of legitimate criticism and skepticism about intelligence research. And most of it is discussed in kind of professional ways, in professional channels, within professional norms. And that kind of feedback, that kind of skepticism, that kind of criticism is absolutely essential for any field to move forward. Intelligence research seems to be a little unique in that it has critics from outside the field who really, in many ways, are not arguing or not presenting their criticism in good faith. These people tend to be very self-righteous, little arrogant, little narcissistic. Some of them actually have a dash of cruelty in the way they approach this. But that kind of criticism really is not characteristic of the field. The field is moving forward. And one of the interesting things about the evolution of the field, as you laid out the 3 different ways to approach this, they're all coalescing now. They're coming together in the same studies with gigantic sample sizes.
Behavioral genomics.
Behavioral genomics, and people who are not traditionally trained in psychometric studies of intelligence, but trained in everything from big data to molecular genetics to cognitive psychology. They're coming into collaborative studies where you will find sophisticated cognitive psychology, sophisticated psychometrics, sophisticated DNA analysis, and sophisticated brain imaging, all done on the same samples with very large numbers. So that's why the field is progressing.